Okay, for our example, let x sub 1, x sub 2 until x sub n be a random sample from the Bernoulli density f of x theta is equal to theta to the x 1 minus theta to the power of 1 minus x for all x 0 and 1. And we assume that the prior distribution of theta be a uniform distribution over the interval 0, 1. So let us consider estimating our theta and theta times 1 minus theta. So let's find the posterior base estimator of tau theta, which is equal to theta. Okay, let me explain it. Okay, recall your beta function. Beta function in your STT131 or STT132. The beta function with parameters a, b is the integral from 0 to 1 of x to the a minus 1 times 1 minus x to the power of b minus 1 dx. So, parang ganyan. So, ano yung nangyari kanina? Okay, isulat natin yung kanina, no? Okay, we have the beta function. Ang parameter niya is summation of x sub I plus 2 and n minus summation of x sub I plus 1. That's for the numerator, and the denominator, we have the beta function with parameters summation of x sub I plus 1 and minus summation of x sub I plus 1. Now, let's write this into the gamma function. Recall. Let's recall. Ano yung gamma function? Your gamma function, if we have the beta function AB, this is equal to the gamma of A times the gamma, that's the gamma of B, all over gamma of A plus B. Ganon. So, let's rewrite this into the gamma function. Sulat natin into the gamma function. So, you try to translate this. Now, your numerator is actually the gamma of summation of x sub I plus 2. And we have here the gamma of n minus summation of x sub I plus 1. Okay, all over. When you sum this up, this is actually the gamma of n plus 3. Bakit naging n plus 3? We have here n minus summation of x sub I plus summation of x sub I, that is cancelled out. Then plus 1 plus 2, that's why we have there. And for your denominator, we have the gamma of summation of x sub I plus 1, okay, times the gamma function with the value n minus summation of x sub I plus 1. All over. This is now the gamma at, when you add this 2, this is n plus 2. Yan. Now, simplifying further, this is now equivalent to, kasi pwede natin ito ma-cancelled out. Yan, cancelled out. Okay, so, let's rewrite this. This is actually equivalent to summation of x sub I plus 1 times the gamma of summation of x sub I plus 1. Ganyan pagkasulat nito. All over, this is n plus 2 times the gamma of n plus 2. Oh. Yeah. Okay, all over. This is, all over, this is summation of, no. Let's not change the fraction in the denominator. So, we'll just copy gamma function of summation of x sub I plus 1 over your gamma function of n plus 2. So that we can actually cancel this and cancel that. So, what is left for our posterior base estimator? We have the summation of x sub I plus 1 over n plus 2. Yan, I from 1 to n. This is now our posterior base estimator for our tau theta, which is equal to theta.